You're welcome to solve this nice exponential equation, which is x minus 3 to power 6. This is equal to 8 to power 6. So what are the values of x? The first thing here, let's take 8 to power 6 on the left hand side. So here we'll have x minus 3 to power 6, subtract 8 to power 6. This is equal to 0. The next step, we can express x minus 3 to power 6 as x minus 3 to power 3, all this squared, subtract 8 to power, can express this as 8 to power 3 squared. This is equal to 0. Now, this actually is in the form of a squared minus b squared, which we can express as a plus b, a minus b. From this equation, a is equal to x minus 3 to power 3, and b is equal to 8 to power 3. Substituting this, then a plus b, this can be expressed as x minus 3 to power 3 plus 8 to power 3. This is equal to, so we have a plus b is equal to x minus 3 to power 3 plus 8 to power 3. This is equal to 0. Let's call this equation 1. And we have a minus b. This is equal to x minus 3 to power 3, subtract 8 to power 3. This is equal to 0. Let's call this equation 2. Now, let's start to solve case 1 here. For case 1, which is equation 1, we have x minus 3 to power 3 plus 8 to power 3. This is equal to 0. Now, this is actually in the form of a cubed. This is the sum of two cubes, a cubed plus b cubed, which we can express as a plus b, a squared minus ab plus b squared. Now, here we'll have x, okay, x minus 3 plus 8, and then we'll have x minus 3 squared, subtract 8 multiplied by x minus 3 plus 8 squared, which is 64. Close the bracket here. So this is equal to 0. So here we have x minus 3 plus 8. So this is x plus 5. And here we have x minus 3 squared. This is in the form of a minus b squared, which we can express as a squared plus b squared minus 2ab. Applying this algebraic identity, then we'll have x plus 5. This is the first part. This is equal to 0. And here we'll have x squared, subtract 6x plus 9, then subtract 8 times x. This is 8x, negative 3, multiplying by negative 8 times negative 3. This is plus 24, then plus 64. This is equal to 0. So here you have x minus 3 plus 8. This is x plus 5 equal to 0. Then we have x minus 3 squared. This is in the form of a minus b squared, which you can express as a squared plus b squared minus 2ab. Applying this algebraic identity, then here we'll have x squared, subtract 6x plus 9, subtract 8x, then plus 24 plus 64. This is equal to 0. So here, the first part here, x1 is equal to negative 5. And the second part here, we'll have x to power 2, subtract negative 6, subtract 8x. This is minus 14x. Then we have 9 plus 24. This is actually equal to that. X1 is equal to minus 5. Then here we have x squared minus negative 6x minus 8x. This becomes negative 14x. Then plus, we have 9 plus 24. Now this is equal to 30, 33 plus 64. And this is equal to 97. This is equal to 0. Now here we form a quadratic equation of the form ax squared plus bx plus c. This is equal to 0. Now in this case, we have A equal to 1, B equal to negative 14, and C equal to 97. Now let's assess the nature of the root of this quadratic equation. Let's determine the discriminant value, which is b squared minus 4ac. So here we have negative 14 squared subtract 4 times a, which is 1, times c, which is 97. So negative 14 squared, this is 196, subtract, now here we have 97 times 4, 7 times 4, this is 28, carry 2, then 9 times 4, that's 6, so we have 388. So here we'll have negative, that is 196 minus 388, this is minus 192, which is less than 0. So this means that we have two complex roots here. We have two complex roots. We have two complex roots here. And so for this quadratic equation, that is for x2 and x3, we apply the quadratic formula, that's minus b plus or minus the square root of b squared minus 4ac divided by 2 times a. So here we'll have minus b, which is minus 14 here, plus or minus, now here we have b squared minus 4ac, which is minus 192 divided by 2. Then here minus times minus 14, this is 14, plus or minus the square root of negative 192. We can express negative 192 as 64 times 3 times negative 1 divided by 2. So here we'll have 14 plus or minus the square root of 64 is 8, then the square root of negative 1, this is I, then square root of 3, all this divided by 2. So we can factor out 2 here, so we'll have 2 into the bracket here, 7 plus or minus 4i square root of 3, all this divided by 2. So if you simplify here, then here we'll have 7 plus or minus 4i square root of 3. This is what is x, this is what is x2 and x3. 7 plus or minus 4i square root of 3. Let's proceed. So we have x2, x3 equal to 7 plus or minus 4i square root of 3. So this implies that x2 is equal to 7 plus 4i square root of 3, and x3 is equal to 7 subtract 4i square root of 3. Now these are two complex roots here. These are two complex roots. Now let's proceed to case 2 here. Let's proceed to case 2. Let's proceed to case 2. So in case 2 here, we have x minus 3 to power 3 subtract 8 to power 3. This is equal to 0. Now this is actually in the form of a cubed minus b cubed, which is the difference of two cubes, expressed as a minus b, a squared plus ab plus b squared. Substituting this, we'll have here x minus 3 minus 8. Then here we'll have x minus 3 squared plus 8 multiplied by x minus 3 plus 8 squared, which is 64. Close the bracket here. This is equal to 0. So here we have x minus 3 minus 8. So this is x minus 11. This is equal to 0 as one part. And then here we have x minus 3 squared. Let us expand this. This is x squared subtract 6x plus 9 plus 8 times x. This is 8x. 8 times negative 3. This is negative 24 plus 64. This is equal to 0. So here we have x4 equal to 11. And then here we have x squared subtract negative 6x plus 8x. This is plus 2x Then here we have minus 24 plus 64. Now this is actually equal to 40. 40 plus 9, this is equal to 49. This is equal to 0. Now, here we have a quadratic equation of the form ax squared plus bx plus c. This is equal to 0. Now, here a is equal to 1, b is equal to 2, and c is equal to 49. So let's solve for x5 and x6 by applying the quadratic formula, which is minus b plus or minus the square root of b squared minus 4ac, all this divided by 2 times a. So here we have negative 2 plus or minus the square root of, now b here is 2 squared, subtract 4 times 1 times c, which is equal to 49. All this divided by 2 times 1. So again here we have negative 2 plus or minus. Now 2 squared, this is 4, subtract. Now 9 times 4 here, this is 36, 6 carried 3. 4 times 4, we have 16 plus 3, 19, that is 19. So you have 196. All this divided by 2. So here we'll have minus 2 plus or minus the square root of 4 minus 196. This is negative 192 divided by 2. So here we have negative 2 plus or minus the square root of negative 192 divided by 2. So in this case, we have negative 2 plus or minus. We can express negative 192 as 64 times 3 times negative 1 divided by 2. So let's proceed from here. So we have minus 2 plus or minus the square root of 64 times 3 times minus 1 divided by 2. So here this is minus 2 plus or minus the square root of 64, this is 8. The square root of minus 1, this is I, square root of 3, then divided by 2. So then here we can factor out 2 here, so that here we'll have minus 1 plus or minus 4i square root of 3 divided by 2. So we simplify here, so that now we'll have minus 1 plus or minus 4i square root of 3. And therefore, x5, this is equal to minus 1 plus 4i square root of 3. And x6, this is equal to minus 1 minus 4i square root of 3. And therefore, that implies that we have 6 solutions to this problem. We have 6 solutions to this problem. We have that x1 is equal to negative 5. We have x2, x3. This is equal to 7 plus or minus 4i square root of 3. And the next step one, we have x4. The next one is x4, which is actually equal to 11. And we have x5, x6, which is negative 1 plus or minus 4i square root of 3. And these are the 6 solutions to this problem. So kindly follow the steps, like this video, and subscribe.